Hi guys, panoorin natin itong harp. At nagtataka nga tayo bakit maraming tubig sa ibang bansa kahit wala naman daw ulan. May naglalagay sa ano nila thumbnail sa wala kuno ulan pero ang lakas ng tubig. Atong din tan-awon bi. Samtangan sa natog sa
construction work started in the mid-90s. In the nature of the facility, there have been many claims by conspiracy theory groups claiming that HARP was designed to control the weather, weaponized to cause disruption and destruction to unaware targets. HARP has also been blamed for causing a 7-magnitude Haitian earthquake of 2010, which was reported to have killed more than 220,000 people.
lakas na ulan din dito, guys.
For the record, the Haitian quake was caused by slippage of a previously unmapped fault along the border of the Caribbean and the North American tectonic plates. Other natural disasters such as the 2011 earthquake and tsunami in Japan, the Moore, Oklahoma tornado of 2013, and a landslide in 2006 in the Philippines have all been reported as a result of HARP use. One of the most ludicrous conspiracy theories is that HARP was designed to control people's minds, along with altering the very fabric of reality. So what sparked all these conspiracy theories regarding HARP? Maybe it was the experiments were performing back in March 2004. Using a 1 megawatt generator, scientists sent radio pulses every 7.5 seconds towards the ionosphere from the HARP mega array of antennas, which covered acres of land. These radio waves travelled 30 miles up, hitting the ionosphere, which resulted in a modest neon light show visible from the ground. Natural aurora happens when electrons from a cloud of hot gas, known as plasma, rains down from space and excite the molecules in the ionosphere. However, HARP was able to create a similar experience by sending powerful radio waves from the ground. Maybe this is why conspiracy theories have their concerns and have created these bizarre and ludicrous theories. However, as documented in the Feb 2005 edition of the journal Nature, this experiment was to improve understanding of the aurora and help explain how the ionosphere adversely affects radio communications. After this experiment took place, the scientists were left with a tantalizing possibility that such radio-fueled emissions could one day form the base for the technology which could be used for urban lighting and even celestial advertising. So the questions are, what is HARP? Why was it made? How does it work? And who owns HARP? Now, originally HARP was owned by the US Air Force, but since 2015 it was handed over to the University of Alaska Fairbanks. Now, technically, HARP is the world's most capable, high-power, high-frequency transmitter for study of the ionosphere. The principal instrument is the Ionospheric Research Instrument, the IRI. This consists of 180 HF cross dipole antennas spread across 33 acres. The IRI is capable of radiating a massive 3.6 megawatts into the upper atmosphere and ionosphere. The transmit-capable frequencies are selectable in the range of 2.7 MHz up to 10 MHz. Since the antennas form a sophisticated phased array, the transmitted beam can take many shapes over a wide angle range. This also results in multiple beams being formed. As well as HARP using active antennas and transmitters, it's also capable of passive reception, which is used to only monitor or listen. This must be the best receiving station on the planet. HARP radio waves heat electrons in the ionosphere, anywhere from 60 to 80 kilometers altitude. But this can also extend as far as 500 kilometers altitude. Now, this creates small perturbations that are similar to the kinds of interactions that happen in nature. With HAARP, scientists can control when and where these perturbations occur, so they can measure their effects. Now, with all that said, what do you think about HAARP? Have you ever heard it on air transmitting? Well, if you haven't, here's a clip of what it sounds like. Now, here's one final thought, which I only discovered while doing my research for HAARP. A user on the internet has created a map which apparently shows more HAARP stations around the world, located in many countries. Now, here's one, which is apparently in the UK. Let me know down in the comments if you've ever heard HAARP while they were transmitting. And I believe they performed some experiments only a couple of months ago. Until the next video, stay safe, thanks for watching, I'll see you in the next one.
Wala na ibahin sa HAARP. Nabulong pa ko bahin ani HAARP. Wala naman. Bulong og lain. Kay tingalata ning nanong kasiging baha sa lain nasod.
Katong si Biden pa purpose na nila sa US.
Students. I was a student here at the University of Alaska Fairbanks, and HAARP at the time held an
Kus
annual
gigamay.
open house where the public could tour the facility.
San auta ani guys, karon pa pud kumulan taw ani.
HAARP's facility is going to be
Kus gigamay kay lakas ang ulan.
60 miles out into space. And that's a region where there's not much density.
Ano man eh.
heat up the atmosphere for a few minutes and you shut it off. And you watch the atmosphere appear.
Lami ang inunan
It
mo
does that in
eh.
a few seconds. You can do a lot of
Wow,
experiments.
pwede na
Things you
mag-no.
do in the laboratory.
Black.
First time I visited HARP, I didn't even know what it was. I went to HARP as part of a physics club, the Society of Physics Students. I was a student here at the University of Alaska Fairbanks, and HARP at the time held an annual open house where the public could tour the facility and talk to the scientists.
HARP is a facility to study the ionosphere region 60 miles out into space. And that's a region where there's not much density. The air is very thin. Mostly plasma, which means electrons and ions.
When I saw this facility and saw how unique and interesting it was, is when I decided to do my PhD thesis research using the HARP facility itself. HARP stands for the High Frequency Active Auroral Research Program.
The federal government spent about $800 million. It's the most exquisite of its kind.
Lami.
It's currently owned and operated by the Air Force.
Barat po.
And they have other priorities. They've done some tests over the years.
Kaunta inununan guys. Oh,
Some of it is morphine.
paksiw na tulingan. Ay, si Bunjo ni
The
doon
U.S.
na
has
po.
the lead in the world in this area, and they tend to get that up. The
Yung
other
kanan ng
facilities
tunog,
aren't nearly as flexible or as powerful. And HARP can do science that the other two can't. The chart that shows compares all the heaters, including your receiver. You can see that there's quite a bit more powerful and more flexible.
Daga na di ay na.
It's an instrument that allows us to make small changes to the ionosphere. And we can measure the response of the ionosphere and the upper atmosphere to the changes that HARP is making. Scientists have categorized the various layers of the atmosphere. Most of the weather that we experience occurs in the troposphere when we fly in commercial aircraft. We're generally flying at the top of the troposphere. Above that is the stratosphere. Above that is the mesosphere. And above that is the thermosphere. And the ionosphere is basically part of the thermosphere, which extends from about 80 to 100 kilometers altitude all the way up to about 1,000 kilometers altitude. And so the ionosphere is generally what we refer to as the partially ionized portion of the thermosphere. It's too high for weather balloons and it's too low for many satellites. And I'm sure we can launch rockets through the ionosphere too, as we do at Poker Flat, but those are very fast but expensive experiments. The reason why we care about the ionosphere, particularly for radio communication, is that radio waves, when traveling through free space, behave differently when they travel through a region of charged particles or plasma. The ionosphere is a basically a partially ionized plasma. And so one of the things that can happen to radio waves that travel through plasma is that they can be bent, their polarization can change, they can be absorbed.
Sus
And
giloy
so
kay
much of our
kusa
lives is
gamit
dependent on
langan.
radio communication, either communicating to satellites or for navigation with GPS, which is also communicating with satellites essentially, or over the horizon communication or over the horizon radar. It's really important for us to understand how radio waves are affected by the ionosphere, and in some cases how radio waves affect the ionosphere in the case of HARP or other powerful radio transmitters.
So a lot of us realize how important it is, how powerful and significant the facility is. So we're trying to figure out ways to keep it alive as an active scientific tool.
Why would it be beneficial? I can't speak for the applications, but it's a mystery to solve. You can think of the ionosphere as a natural plasma laboratory, the conditions of which are difficult to replicate in an actual physical laboratory. And so this is just another way of learning about
Sila na
the
na
physical
kayo.
laboratory.
Ay, dugay naman di ay
Because
na.
the Air Force shuts it down, by prior agreement, they're required to remediate.
Sa inyong po bago ra.
You have to go back and turn the land back into the way it was before they started. They'll have to bulldoze both sides away.
Na, bayo na guys. Kailangas na ang gangis.
HARP animation.
Naapo di ay animation anak.
At lalo ko ang tantang animation.
Sa ato pa AI ang gahimo.
Wala pa nang AI na ano.
Thank you, Lil Doggy.